So welcome, this is part 2 of the video related rates. In part 1 we have done 6 questions. Now we are starting from question number 7 from the past paper questions based on the topic related rates. Below is a sketch of a Ferris wheel, an amusement park device carrying passengers around the rim of the wheel. The circular Ferris wheel has a radius of 10 meters. So the radius is going to be 10. So this is 10 over here, and I draw it out over here, that is 10, and over here also it's going to be 10. And it is revolving at a rate of 3 radians per minute. So d theta by dt equals to 3 radians per minute. So I'm going to write d theta by dt equals to 3 radians per minute. Determine how fast the passenger of the wheel is going vertically upwards. So what is happening? We are considering the vertical height. That's going to be the variable. So let it be equals to y, because vertical axis is y-axis. So how fast is it going? Dy by dt equals to question mark, and when y equals to 6 meters. So we know that this is 10, this is 6, so by Pythagorean triplet that has to be 8. Now we know y and 10, so it is sine theta. Sine theta equals to y upon 10. So y equals to 10 sine theta. So first frame an equation, then differentiating on both sides with respect to t. Dy by dt equals to 10 sine theta derivative is nothing but cos theta, d theta by dt. I need to know cos theta. So we know that from the Pythagorean triplet, cos theta equals to adjacent side upon hypotenuse, 8 upon 10. So plug in that values over here, 10 times 8 upon 10 times 3, which is nothing but what? 24 meters per minute. That's going to be the answer. Next part, the operator of the Ferris wheel stands directly below the center such that the bottom of the Ferris wheel is level with his eye line. As he watches the passenger, his line of straight sight makes an angle alpha with the horizontal. Okay, so from the operator, this particular angle is alpha, and we know this angle was theta. So alpha and theta. So now I have to find a relationship between this alpha and theta, because he's asking find the rate of change of alpha. So he's asking us to find it out, d alpha by dt. Anytime rate means with respect to time, d alpha by dt. So I have to find it out a relationship between alpha and theta. Now when I zoom this one and check, this particular angle will be 90 minus alpha. So I write it out over there. It is, or else right over here, 90 minus alpha. So over here also the angle will be 90 minus alpha, because two sides are same, the radius 10 and 10. So the remaining angle will be nothing but how much? The remaining angle, this angle will be theta plus 90. So we know that in that big triangle, let it be A, let me write it as AOB. In triangle AOB, sum of all angles is 180 degrees. Triangle AOB, sum of angles is 180 degrees. 90 minus alpha plus 90 minus alpha plus theta plus 90 equals to nothing but how much? 180 degrees. So what can happen? 90 is 180, 180 gets cancels. Negative 2 alpha plus theta plus 90 equals to 0. So 2 alpha equals to theta plus 90. Alpha equals to theta upon 2 plus 90 upon 2 pi by 4. You can write it as 45, or pi by 4 is the best way, radians. So this is alpha. Now what do I find it out? I want to find d alpha by dt, differentiating with respect to t on both sides. So 1 upon 2, theta by 2 derivative is 1 upon 2. Again theta derivative is d theta by dt. Then plug in over here, plus pi by 4 derivative 0. 1 upon 2 times 3. So which is going to be nothing but how much? 1.5. So alpha is radians per minute. That's going to be the answer. So just we need to get an idea that alpha equals to theta by 2 plus pi by 4. I used sum of all angles in a triangle is 180 degrees. By that I could able to get a relation between alpha and theta. Now question number 8. The diagram shows a circle with a center O and radius r. A point P x comma y is moving around the circumference of the circle. M equal to tan of sine inverse of y upon r. Over here, y upon r. Given that dy by dt equal to 0.001 r, show that dm by dt. So m equals to tan of sine inverse of y upon r. So I want to find it out dm by dt. So differentiating with respect to t on both sides, dm by dt equals to tan derivative. We know secant square. Secant square sine inverse of y upon r, chain rule. Now the role of tan is over. So let me write it out over here. Derivative of tan theta. From the formula booklet, I think so it should be there, secant square theta. Next I want derivative of sine inverse of x. 1 upon square root of 1 minus x square. This is the formula for sine inverse of x. So role of tan is done. This is role of tan, chain rule, I'm using it out. Next, sine inverse derivative is 1 upon square root of 1 minus y upon r whole square. Role of sine inverse is also done. Then y upon r derivative is 1 upon r. Then again y derivative is dy by dt. So I have used the chain rule. First derivative of tan, then derivative of sine inverse, then derivative of y upon r, then derivative of y. Now I have to simplify this one and get that value, whatever is given. So for this, we have to learn it out. Sine inverse x. So I have to convert this sine inverse r into cos inverse r. So how do I do it? So that cos inverse and secant are reciprocal to each other. They can get cancelled. So what am I going to do it out is, here down, I'm going to do that. Sine inverse x equals to cos inverse of square root of 1 minus x square. Sine inverse x equals to cos inverse of square root of 1 minus x square, because we know that sine square x plus cos square x equals to 1. Sine square x plus cos square x equals to 1. Based on that concept, what we can do it out is, sine inverse x can be written as cos inverse of square root of 1 minus x square. Or else, if at all cos inverse x you want to convert into sine inverse x, it is sine inverse of square root of 1 minus x square. These are the formulas that need to be remembered. So now over here, what am I going to do? Secant square. This is sine inverse. So it becomes cos inverse of square root of 1 minus y square upon r square. Then 1 upon square root of r square minus y square upon r square times 1 upon r times dy by dt. dy by dt has been given as how much? 0.001 r, which is r upon 1000. For simplification, just cancel r and r wherever you can. Now once I written that sine inverse as cos inverse, now I need to simplify it further. But we know that secant and cos are reciprocal functions to each other. So therefore, what am I going to do it is, secant square can be written as 1 upon cos square, and cos inverse of square root of r square minus y square upon r square times this square root of r square is r, which goes to the numerator, r divided by square root of r square minus y square times 1 upon 1000. So now cos and cos inverse gets cancelled, but there is square is still left over. So 1 upon cos of cos inverse of square root of r square minus y square upon r square whole square times r upon square root of r square minus y square times 1 upon 1000. So what does it happens? Cos and cos inverse gets cancelled, square and square root gets cancelled, this r square goes to the top, so r square upon r square minus y square times r upon square root of r square minus y square times 1 upon 1000. So it becomes r cube upon 1000 is 10 cube, r square minus y square whole power 3 upon 2. So what we can see, 3, 3, 3, everything is 3 is common. So it is r upon 10 square root of r square minus y square whole cube. So a bit complicated one. This is a way. How am I going to get it out? dm by dt. Next, what is he asking? State the geometrical meaning of m. So m is nothing but what? The slope. Because we are talking about tan. Tan always gives you the slope or the gradient. So therefore dm by dt, what does it represent? Dm by dt represents the rate of change. Rate of change of what? Rate of change of the gradient. Rate of the change of the gradient of the line OP. That's question number 8. Now coming to question number 9. A helicopter H is moving vertically upwards with a speed of 10 meters per second. So dH upon dt equals to 10 meters per second. The helicopter is h meters directly above the point Q, which is situated on the level ground. The helicopter is observed from a point P, which is also at a ground level, and PQ equals to 40 meters. The information is represented in the diagram. H equals to 30. Show that the rate change of HPQ is 0.16 radians per second. So this angle is theta. So we have to find d theta by dt equals to question mark or 16. So I use tan theta. Tan theta equals to h upon 40. So h equals to 40 tan theta. Now differentiate dH upon dt equals to 40. Tan theta derivative is secant square theta. Theta derivative is d theta by dt. Now I want d theta by dt. So d theta by dt equals to dH upon dt. What was dH upon dt given? 10. 10 divided by 40 secant square theta. So which is nothing but what? 1 upon 4 secant square theta. So cos square 1 upon secant theta is cos theta. Secant cos square theta upon 4. So what is cos theta from here? So this one was 30. So Pythagorean triplet, this has to be 50. So cos theta will be adjacent side upon hypotenuse, which is 4 upon 5. So 4 upon 5 whole square times 1 upon 4, which is nothing but what? 4 upon 25, which is nothing but how much? 0.16 radians per second. That's going to be the answer. Find the rate change of pH. So for that we are going to use the Pythagorean theorem. X square, let pH is x. X square equals to h square plus 40 square. So x square equals to h square plus 1600. So pH equals to x. Don't forget to write it. So now differentiate on both sides. 2x dx upon dt equals to h square derivative is 2h, dh upon dt 1600 derivative is 0. Now I want dx upon dt equals to h is nothing but 2 gets cancels. H is how much? 30, and x was, what was x over here? Has he given any value of x? X is, we have, when it is 30, we have to know that value of x also. So or else first of all let me write it out of x times dh upon dt. Let me write it out over here rather than writing h value now itself. I'll write h upon x dh upon dt. So let me quickly add a page over here. So I get dx upon dt equals to h and upon x. What is x value? We can get it out from over here. X is square root of h square plus 1600. Square root of h square plus 1600. Dh upon dt was 10. So it becomes 10h upon square root of h square plus 1600. Now h is 30. So plug in 30 over here. Square root of 30 square plus 1600. So which is nothing but how much? 6 meters per second. That's going to be the answer. That was question number 9. And the last question for this video will be question number 10. Sand is being poured in the form of a cone of a height h and a base radius r. The height remains equal to the base radius. So h equals to r. Height of the cone is increasing at a rate of dh upon dt equals to 0.5 centimeters per minute. Find the rate at which the sand is being poured. So dV by dt, volume, equals to question mark. So what is the volume of a cone formula? 1 upon 3 pi r square h. So 1 upon 3 pi r square, h is also nothing but what? R is also h, so h. Because he has given h, so we eliminate r. So it becomes 1 upon 3 pi h cube. Now dV by dt. So 1 upon 3 pi h cube derivative is 3h square. H derivative is dh upon dt. So 3 and 3 gets cancels. So dV by dt equals to pi h square dh upon dt. Pi h, what is the height has been given? It is 4 square, and dh upon dt given as 0.5. So simplify that, it becomes 8 pi or 25.1 centimeter cube per minute. That's going to be the answer. So that completes the question. Those are the questions based on related rates from past paper questions. See you in the next video. Bye.